Hello my dear students, today we are going to continue our topic about conductors and insulators. I hope you have studied them well and the examples we have studied in our previous lesson. Okay, we are going to continue the structure of thermos. Do you remember the structure of thermos? So yes, this is a thermos from inside. This is a thermos from inside. How does a thermos work? Let's see together how does a thermos work. First of all, there is inside a glass lining. Inside it, there is a glass lining. You can see these two blue layers. These two blue layers are two layers of glass. So this glass lining or the layer of the glass holds the tea and keep it warm because the glass, as we said before, doesn't conduct heat very well. The glass is an insulator. Insulator means keep the liquid inside tea or coffee or whatever, milk or any liquid, keep it hot for a longer time. So again, the glass lining, this glass lining from inside holds the tea or holds the liquid inside hot, and as the glass doesn't conduct heat very well. And by the way, between the two glass layers or the two glass sheets, there is something called vacuum. Can you see the vacuum? So here is the vacuum which keep the liquid inside always warm or hot for a longer time. Okay, here is the vacuum. So let's start with vacuum. As we have said, the vacuum is between inner and outer layer glass. The inner and outer layer glass of the bottle, the vacuum is between them, so it keeps conduction or convection from taking place. Okay, again, it keeps or avoids conduction or convection from taking place. What about reflection? Reflection, even in a vacuum, radiation can move energy. Do you remember radiation? Radiation move energy inside the thermos, so the liquid inside will be always hot. It makes a radiation, or the radiation inside can move energy inside the thermos by the facing sides of the layers are coated in silver. There inside there are two layers. The facing layers are coated in silver, which act like a mirror. And you know that the mirror reflects light. As mirror reflects light, okay, so we can see ourselves in mirror. Here is also the mirror inside, or these coated layers inside with silver, which act like a mirror, reflect some heat back. So that's why the liquid inside becomes always hot for a longer time. So again, the inner structure of the thermos consists of glass lining, number 2, reflection, okay, which depends on radiation of heat, number 3, vacuum, which is inside between the two glass layers, and be careful or note that conduction, convection, and radiation, all of the three transfer way of heat, slowed down so that the tea or the liquid inside stay hot for a longer time. Okay, again, conduction, convection, and radiation, I mean all the ways of heat transfer slowed down, so the tea or the liquid inside stays hot for a longer time. This is the thermos construction or the structure of the thermos. Now let's talk about another point, which is heat proofing a home. What does it mean, heat proofing a home? For example, this home, how to make this home lose less heat? First of all, heat proofing means what? For example, you know when the weather is hot, you want to keep heat from coming into your home, right? You don't like heat to come into your home when the weather is hot. And when the weather is cold, you want to keep heat from leaving your home. You don't like heat to leave your home. So it costs money to cool and heat a home. So there are different ways to slow the heat, to slow the flow of the heat into or out of your house. So there are some things need to be done while the house is being built, and others can be done as an existing home. Okay, so insulating a home saves money. insulating the home saves money to keep it hot or to keep it warm in winter or to keep it cool in summer, and it also helps in saving energy. So we can save energy and we can save money by roofing a home. So let's see how can we heat proof a home. Actually, there are several ways to heat proof a home. For example, or the first one is insulation. Insulation means what? Insulation, like you see this man? This man is blowing air or blowing a liquid or material inside the walls of the house. Inside the walls of the house. Why? Why? Because it keeps heat from traveling through to the attic. Do you know the attic means the roof of the house? Do you know the roof of the house? So by this way, by putting this material inside the walls of the house, it keeps heat from traveling through the attic or through the roof of the house. So this is the first one, the first way. Second way, about windows. Most European countries now and in America use this kind of window. This kind of window, it consists of, or it contains two glass sheets, as you see in the picture, or two glass panes. Why? These windows, again, to have two panes of glass to limit conduction. And by the way, there is air between these two glass sheets or two glass panes. Why? Because they also have a coating that limits heat radiation. Again, it limits conduction. This kind of window, this type of designing the window, doing what? Limit conduction and limit heat radiation. So always the heat in the air inside or the weather inside home always warm, even if in cold weather, by using this kind of insulating window. Okay. Number 3, about the pipes. You know the water pipes? Also the water pipes, very important. The hot pipes radiate heat from the water into the air. The hot pipes radiate heat from water into the air. So by this way, the water inside the pipes will be cold. So we want it to be hot all the time or warm all the time. What should we do? Wrapping them. Keep the heat from escaping. Wrapping them keeps heat from escaping, so the water will be hot all the time. Okay, by insulating or keeping them away from by wrapping them so the heat cannot escape out. Number 4, the soil. Actually, the soil is considered a great insulator. How the soil is a great insulator or a good insulator? Because basements, these rooms built downstairs or underground the house are usually cool. When you enter the basement, it's usually cool, even if in summer. Why? Because above it there is a soil, and the soil actually is a great insulator. It doesn't allow heat to pass. That's why basements are usually cool, even if in summer. So these methods for proofing a home, heat-proofing a home is very important and saves money, saves heat, saves energy for the house. For example, let's see a solving real problem, world problem. How? For example, and see if it is good or bad. Let's see together. For example, a family wants to heat-proof their house. Okay? A family wants to heat-proof their house. They can save about $800 a year by adding insulation. Here is number 1. Wrapping the water pipes will save an additional $60 a year. Here is number 2. And by buying a new energy efficient windows, those kind of windows, as we have said since a while, will save them about $2,000 every year. Can you imagine how much this family can save money and also can save heat? So by adding insulation, they can save $800 a year. By wrapping the water pipes, they can save additional $60 a year. and by buying these new windows or the insulating windows, they can save about $2,000 a year. So it's very good, perfect, right? Very good idea, saving money, saving heat, and saving energy. Now let's do an exercise together. This exercise you have it at in your book, page 470. We can solve it together now, and another page you are going to take it as homework. So here it said that write the vocabulary term that describes each material. Here is a metal cube, here is a hat, okay, and here is a rubber band. So which one is conductor, which one is insulator? Let's see. This hat, by the way, used for winter, heavy like heavy clothes. So metal cube, do you remember the metal? The metal, was it conductor or insulator? Yes, conductor, as we have said before in our previous session. And this hat, heavy clothes, do you remember? The woolen clothes, they are insulators. And rubber band, we have said before that rubber is used for covering the electric wires because it is a good insulator for both heat and electricity. So this one is conductor, second one is insulator, and the third one again is insulator. Here is another exercise. Draw a box around the correct answer or answers. Okay, draw a box. But for me, actually, I cannot draw a box here. I'm gonna put for you a smiley face on the right answer. Okay, you can make a circle or you can draw a box in your book, but here I'm gonna put a smiley face. Number 4. Heat moves easily through it. Heat moves easily through it. So it is conductor or insulator? Conductor. Number 5. Heat doesn't move easily through it. Doesn't allow heat to pass through it. So it will be an insulator. Yes. Solids often do this to heat. Solids, do you remember? We have said that solids are good conductors or insulators. Conduct. Yes, solids often do this to heat, so solids conduct heat. A thin layer of trapped air can do this to heat. A thin layer of trapped air. Do you remember it? Insulate or conduct? Insulate, yes. Which forms of heat transfer do insulated bottles prevent? Now, in insulated bottles, as we have said since a while, in thermos, which one of these used in insulating bottles? Which form of heat transfer do insulated bottles prevent? Which one? Actually, all of them. Conduction, convection in case of the vacuum, and radiation in case of reflection. Yes, so it will be conduction, convection, and radiation. All of them in the structure of the thermos or the insulated bottles. The last one, wrapping hot water pipes prevent which form of heat transfer? Wrapping, as we have said since a while, wrapping hot water pipes prevents which form of heat transfer? Radiation, of course, yes, radiation. Okay, so study well this exercise, and you can do this word play as homework, and we are gonna correct it together in our next meeting. See you, my dear students. Bye bye.